All right. Hey everyone, welcome to the stream. Okay, so in the last stream we did the handling of variables, and I think we were going to create the logic for handling expressions. So let's check. Symbol writer compilation engine. Let's go into compilation engine.py. Handling expressions, challenge expressing about semantics in the VM language. Yeah, that's the challenge, isn't it? Let me also open up the grammar. And I think we'll need the VM slide as well. Which one is it? I think it is this one. Why is my browser slow today? Do I have anything open? Let me check the system monitor. Memory, CPU. Yeah, the CPU usage is a bit high. It's taking so much of memory. OBS. I didn't know OBS took that much of CPU power. Brave. But I don't have many tabs open. I have the usual number of tabs open. Let's just hope that the functioning gets smoother. Because everything that is open right now is what we need open. I don't have any unnecessary things open. The hell with it. So let's see. Grammar, where's the grammar? Variable names. We took care of this variable name in the term. What are we going to do now? Yeah, this expression part. So for the variable, the VM code will look like this. That's all right, but let's see. Symbol tables, life cycle, yeah. Handling the expressions. So this is the thing that I'm not sure about how to exactly handle it. So they have given a subset of grammar. Yeah, we can have this kind of expressions, different kinds of expressions. fix, and the expression in jack language is in fix form, obviously. And for the VM language, we need to convert it into postfix notation, which is stack oriented. This is the a bit complicated part. Alright, so if this a two-stage approach, when executed, the generated code ends up leaving the value of the expression at the top of the stack. Parse tree, yeah, right. And I think it is depth first search. So this is how it works. We go to the root node X, then another root node of this G to push it on the stack, Y, Z, go back. We don't have anything here, so we put minus, push minus on the stack, and we go back and push right up. Yeah, we call G, and after that we don't have anything, so after that, oh yeah, we push that phi, then we push plus, and the finally, wait, what about this minus? Is it minus? Yeah, it's definitely minus. Wait up, this example is, I think, incorrect. I don't know. Okay, so this is a two-stage approach, but according to the slides, we don't need to follow a two-stage approach. We can get away with a one-stage approach according to what we have implemented already. Right, so well, we still need to write this logic, I guess, but I'm not sure where I should write this. Let's see. If this is the source code, what do? We pass it as an expression. Alright, okay. After that, what? If the expression is a number, we push and okay. Yeah, right. Let x is equal to a plus b plus c. It generates this XML code already right now. Instead of this XML code, it should generate this pseudocode. Not the pseudocode, it should generate the actual game code, but yeah, that's the gist of what it should do. Right. And the expression, no wait, it's a let statement. Wait up, let me check the grammar. And the expressions can be in other statements as well, like if I and return. So not only let statement, right? Okay. Left to right priority. All right. That means A first, A is pushed first, B is pushed second. Yeah, right. After that we push the symbol. Then we push C, push star. Alright. Specifies that the expressions in parentheses are evaluated first. So this is the thorny part. We have a left to right priority, and if the parentheses are present, then the expression inside the parentheses is given the priority first. Check language dishonest is actively the that was it. Okay, let's see how we can implement this stuff. We need to check compile expression. Do we even have compile expression? Yeah, right, we do have a compile expression. Wait, this is compile expression list. Yeah, here's the compile expression. Okay, so what should we do here? Let's see. Wait, I think this is pretty much easy. Let's see. Wait, but does this pseudocode take into account the parenthesis logic? I don't think so. Let's see. If the expression is of this type, expression 1, OP, and expression 2. Right. It directly writes the expression first, then expression 2, then OP. Should it do that? What happens in this case? Let's see. We pass this as the expression. This is the first expression, this is the second expression. Yeah, it won't work probably, or maybe it will. Let's see. If it is a recursive function, what happens? First we call expression A, and after that we call expression B star C. So what happens when we call B star C? It prints B, then C, and OP. Oh, right. Yeah, so it does work. Great, great, great. I think it is not that much complicated. Let's write the logic. But now how do we implement the recursive function inside this function? If we modify this function, let's try to copy it. No, not up to 18. I want up to 21. Yeah, yank it and paste it. Right, this is the code, so let's comment this code so that we don't lose it. Alright, so let's now try to modify this compile expression method. How can we implement this logic in this compile expression? I think I know how to do it. Ooh, what the hell? I probably need to reorder this function call in here. Okay, difference between this method and this logic is here we have an expression, and here we are just passing the token, the first token of the expression. So this is a bit different. Okay, but the thing is, okay, let's do something like this. Operator token equal to token. Let's save it. Let's do something. Yeah, this will work. Let's see. Write op VM code. So what we'll call in this case is, what did we call? Was it VM? Yeah. Oops. What the heck? VMW dot what functions? Which function should I call? Let's check. I need to check the API of the symbol table. No, not the symbol table, PM writer. Push pop command arithmetic. Yeah, arithmetic. Right, arithmetic. I can't directly call it. I need some kind of logic. So need to check if op token equal to, let's say if it is plus, in this case the pass add as a command. If op token is what? Subtract, that means this. In this case should pass sub. If op token is wait up. Now this is, so how do we know if we have to call, whether we should call subtract or the negation operation? Because in both cases the op token will be this one. Let's see. So in this case, let's see. Yeah, it is this one. The expression is like this, op and expression. We need to first call expression and the op. In this case the op will be negative. I think we didn't take this thing into account while creating the compile expression. So the code which we already have, what happens in this case? Wait, it doesn't even take into account this kind of source code? What the hell? I didn't think this would be the case. This is messed up. Let me check the grammar. Expression, yeah, right. Yeah, term can be. Okay, we take we take care of it in the compiled term. All right. What does that mean though? Yeah, that means we don't have to write this, the logic for, what is it, negation here. So let's keep it and let's check other operation. We have equal to, greater than. These are all the opcodes, right? I need to check the grammar again. Yeah, it is one of the opcode. Plus, minus, and unary operation. What the hell is this one? I know this is negation, but what are this? I don't think we have this kind of unary operation. Wait, is it a flip? Flip? What the hell did I do? Yeah, it is a flipping, but we don't have that kind of operation in the VM code. Right? I need to check. Stack. No, this one. It's the VM code. Where's the freaking VM code? Yeah, it is one of the logical commands, I guess. This is negation. Yeah, right. But what about the tilde one? I don't think we have that kind of operation or operator available in the VM. Do we? Wait, is it not X? Oh yeah, I think it is not X. Yeah, right. Only for that, I need to refer to the VM, not the VM, but what is it called? Jack language specifications. What the heck is it? High level language. Yeah, this one. Looking for data types, syntax, classes, methods. Looking for the operators. What kind of operators do we have in the check? List freaking processing. Ah, yeah, it's this one. I think it is a not operator mostly. Symbols, constant identifiers. It should be here in the symbols. What? Yeah, operators. These are the operators. But they don't say anything about this. Okay, let's suppose it is a not operator. Doesn't matter. So now, according to the grammar, this op can be either of these things. So we already did take care of plus and minus, which is addition and subtraction. We have multiplication, division, and operation or operation less than, greater than, and equal to. We are right. Do we have the equivalent VM? So what's the third one again? Multiplication. Wait a minute. We don't have a multiplication here. What the? If we don't have a multiplication, we need to call the library function math.multiply, right? Oh, freaking hell. Do we need to write other code in this case? Or do we need to call a function? A specific function? Let me check. What should I check? Yeah, what do we have for the multiplication? My library functions. Wait, I'm getting confused. Let me open up the API of Czech language. What is it going to be? Czech convention. Is it this one? Czech error code. Czech OS API. What the hell is this? I don't think we need this, but yeah, math.multiply we probably need to call. Yeah, right. Even Czech language doesn't have a multiplication operator, right? Am I right or am I wrong? 11, 9. What's this one then? It seems we do have a multiplication operation. This is freaking... Check. Multiply. Are they using multiplies anywhere? Yeah, they're using it here. Okay, so if it is a library function, what the hell are they giving us that operator? This operator. How can it be present in this thing? Wait a minute, let me check the examples. Absolute. The heck is absolute? Let's just forget about it. I don't think we have a what? Multiplication operator, right? Because it is a function, so it will be taken care as a function. Let's just forget about it. So what's next then? Addition, subtraction. Yeah, let's take care of the logical operators. Right. Let's start with equal to. Start with AND. So if the op token is AND, we should call. Should we call equal to AND? Right. And if it is OR, this symbol, then we should call OR. What else do we have? And or less than. I think it is called LT. Yeah, LTGT or not. LT. Whoops. This is greater than. Less than, greater than, and finally equal to. EQ. Okay, we have taken care of all the operators. Plus, yeah, minus, and or less than, greater than, equal to. Let me check the API. We have called add, subtraction, negation. I will call it later. Equal to, greater than, less than, and or not. And I think this is correct. What this will do? Let's see. Should I test this? I don't know. Let's see. Let me first complete the expressions, other expression. Yeah, let's go back to, where was it? The logic, the pseudocode. Yeah, this one. So we have taken care of the OP part of this kind of expression. I think we should now go into compile term, and here let's say oh wait, I think it is already taken care of. Push, 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 push. Yeah, push. What if it is a constant? Are we taking care of the constant thingy? Wait a minute. What if the identifier is constant? I think we might have a bug here. What's the freaking constant term? Yeah. All of these are terms, right? Yeah, integer, constant, string, constant. Ooh, 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 ooh. Okay, we are not taking care. Kind of token. It can be a freaking constant as well. We haven't written the code for the constant. Whoa, 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 whoa. How is this possible? Let me walk through the code from the starting. If the token is this, yeah, it means it is this kind of thing. Token in this, well, in this case, it's a unary operand term. Else, so everything else is in the this else condition. So what's print dot tag? Yeah, right. Token dot type. Check the tokenizer. Oops. Token type of the constant is an integer constant. Right? Yeah, like that, right. We haven't even taken into account that we can have an integer constant and a string constant. Can we have a string constant? Yeah, absolutely. And is it going to be a token? Okay, we'll worry about string constant later on, but let's first have let's take into account that we can have a string constant. What's up with the keyword constant? It will be under identifier as well, right? No. Okay, it doesn't matter. Let's see. We'll have to write a condition probably here. This whole thing is part. What the? We have this if condition. If the self dot token type is equal to identifier, what if it is not an identifier? If token is keyword integer constant self dot tkz dot token type is what? It is an integer constant. Oops, what the heck happened? Let's go back to token as well. Integer constant. Yeah. What if it is an integer constant? We probably call bmw dot right. Yeah, constant. It is a constant. That means we need to call right push. Yeah, we didn't take into account that we have a constant in this case. Okay, the type will be constant and index. What's the index in this case? Are we going to have an index or not? Are we? We can obtain the index using what? Self.st. Okay, so I need to check two things. First, VM writer. So write push segment. For constant, we don't have an index, right? Let me check. Or do we have it? Constant. I think it is not here. It's here. Yeah, constant. Memory segments. Pointer manipulation, obviously. There's the part about constants. Yeah, in this case, constant is the constant itself. It's not an index, so what should we do? Yeah, let's go back to yeah, we should pass the constant here, obviously. It's the token itself. Right? Yeah, right. Okay. This is good. This is good. What else? If the token type is equal to integer, we call self.vmp.write post constant. Yeah, what after that? So it takes care of this part, and we have taken care of this variable part as well. Right? Yeah, right. This is the part where we take care of the variable things. But wait a minute. What about this other types? We have a constant, so we did take care of constant, arg, local, static, and yeah, static field is, yeah, so we took care of this segment, argument segment, local. Wait up, should I pass the segment in this form? Oh man. No, because we are directly writing the segments. Better I write it in the original form like this. Static fill. Alright. So we have static, we have this. We have argument and local. and constant as well. What's remaining? Yeah, we haven't taken care of that. Yeah, that is for the array, right? And the pointer and temp. Yeah, pointer and temp is in. Yeah, okay, this is correct. This is enough. Yeah, enough. This is enough. So now let's continue. Not now. So we've taken care of all these three conditions. Right. What else is remaining there? What if expression is of this type, of an expression? Yeah, so we haven't taken care of this kind of thing, which will be here. Token in this. If you print the token, call compiler. What should we do here? Probably first we call this, and after that we write the token. Yeah, so should do the same thing here that we did previously. Let's call it. Let's just call it op token. Unary op u op token. Yeah. And after we call compile term, we will check if u of token equal to this, and in this case we call self dot bmw dot write arithmetic. What should we pass? Negation. Yeah, it's obviously negation. And lf u of is tilde. We should call not. Awesome. This one is taken care of as well. And now finally we have functions. Right, let's get to the functions. When I say functions, it means a subroutine call. Right. Yeah, right. That's why we don't have a separate compile method for subroutine code. The instructors have really thought through the implementations, it seems. They have made the implementation of the compiler very much easier. I can't imagine what the implementation of a advanced compiler looks like for a real language. Mhm. Okay, so let's see. Yeah, right. So what is inside the expression? It's an expression. Okay, that means we have already taken care of this too. Writing of the expressions. All we need to do now is call the function. Call write function. Name and okay, but what will it look like? Name. In case of subroutine, subroutine name. In case of class name and variable name, what will it look like? Yeah, right. Okay, we'll see it later on. So I think this is enough. Let me check if we have a test program for the simple expressions. Compiler, is it compiler 1 or 2? I think it's 2. Dot check. Okay, these are test programs. Right. Let's check this test programs. Oh, come on. Nand2Tetris projects. Is it 10 or 11? Yeah, it is 11. 7. Let's go inside 7. Main dot check. Let's check it. Main dot check. We have a simple class. Main do outprint. A do statement and a return statement. So let's focus on different things. Let's not worry about this call F now. Let's jump to, it is almost finished, so let's complete flow of control. Maybe we'll do it later on, but for now we need to take care of return and do statements. Damn, this is freaking convoluted. Let's see. I think I'm going to take the break now for the dinner, and I will continue from here afterwards. So, let's see. I will see you guys after dinner break, and I won't be back in a minute. I will be right back after dinner. Alright then, I will be back after dinner. And maybe I'll keep the should I keep the music running? Okay, it doesn't matter, so let me just I don't know which music, which song is running right now. Let me check. Yeah, I will keep it running. It doesn't matter. Let me get rid of the camera. Right, I'm back. So let's continue. Okay, let's read the code for handling flow of control. If else, yeah. And we also have while. Okay, for the if code, the VM code will look like this. What's this? Yeah, expression not if go to L1. Yeah, right. Yeah, I gave myself a haircut. I did it at my home. Self haircut. Because of COVID, I can't go out. That's why, you know, I said, you're playing chess. Awesome. On which website? Chess.com or Lichess? Not expression. No. Statement 1. Yes, statement 2. Yeah. While expression. What the hell? Need to reload it. Okay. Losing. Well, yeah, it doesn't matter. Lichess. Yeah, I was doing the puzzles earlier in the afternoon as well on the lichess.com. You know what? You should probably teach me chess because I'm at a very beginner level. I want to learn it more. While expression statements. Alright, so this is the VM code for while. Let me check the grammar. While and if. Let's check compile. What the heck did I do? Compile it. If token. This is the expression part. I think it will be easy, not that much complicated. So let's see, let's check the if part. expression, then these are the statements. Else part is this one. Okay, how the heck should I handle this? So when I call compile expressions, it will write the code, VM code for the compile expression, right? So after I do this, it call not, and if should I do it here? Yeah, I think we should do it here. Self dot bmw dot, what's the method again? Write write arithmetic, write arithmetic and not. Alright, so after we have compiled the expression, we call write arithmetic not. This is write what? Write the not of exp. Okay, and after that we have to write if, we have to call if code, but yeah, this is so f42, so we need to call write if, but yeah, now comes the question, what should be the label in this case? There can be multiple if statements in a single program, and yeah, what should be the label in this case? And these labels have to be unique, but wait, should they be unique in a single VM file or in all the VM files? Wait up, what if I give name like the file name, the VM file name, and dot if, and this, it will be much better. If L1, I need to let's see, L1, okay, let's do something like this. Write if go to label. Else case. This is an else case label. Self dot vmw dot write if, and we need to pass a label, so yeah, we need the file name. Do we have the file name? Path, it is in path. but we just need the file name, not the whole path. So dot file name. We can use an OS function. First we have to import OS. OS dot path. How to get the base name of path in Python. OS the path of base name. So you can call OS the path base name, and we need to pass the path. This will give us the file name. And we can use the file name here. Wait, why is this malfunctioning? It is not. File name self dot file name underscore right now will be something like this, underscore if L. Okay, we probably need a number here. If ind, let's call it if ind, and we need to create a new variable self dot if ind, and whenever we use it, we need to increment it afterwards. So let's first of all create that variable. What is it called? If. Okay, while we are here, let's also create a while index. So initially it will be 1. It will be 1 initially. While int so after we use it, we'll increment if end plus equal to 1. Is this correct? Wait. Let's go to, yeah, this is correct. We have a problem because we also need to write the right label. So if go to label 1, we have to also write a VM command just for label L1. So we do need this whole name again. So we'll need to store it somewhere. So yeah, let's just store it in a variable called local variable, and we'll call it yeah, let's call it L1. It doesn't matter because it's a local variable, and and here we can just use L1. That's good. Let's paste it here. So now we have L1, and so we have returned the not what, not operation. After that we have written if go to, and we need to add statements one. So where are the statements? It's over here. Okay, nice. So write the statements, and after that yeah, go to, we need to write go to L2. So and what should we, let's just write it here. Write go to L2. So now we need to get L2. Okay, the label will be of the same format as L1. So let's just copy it. The only thing we need to change, wait, no, we don't need to change anything. This is enough. And after this we will do self dot if int equal to, okay, and after that we'll call self dot bmw writer, write what's the method name, write go to, and we will pass L2. Wait up, we only need L1 label if we have compile statements. We have else statements, not compile. Well, it doesn't matter, right? We don't need to optimize our code, just write it. Oh, nice. Won 2 games. What's your score again? It was around 900 or something, right? Well, I played 2 games earlier and I lost both of them. So there you go. You reached 100. 100? I'm talking about your score. It was something like 900, right? 1000. Oh, that's nice. You need to teach me then how to play chess, because I don't know, my score is, it may be around 300, so pretty much beginner. Yeah, I know, and even he streams on Twitch as well. He has a channel. Let me change this music. I hate this one. Night to night. And what's great about Lichess is it is totally open source. So that guy has open source all the code, which is pretty nice. Ah, yes. I think he has like a, I don't know, donation Patreon or something for that. He doesn't even have ads on Lichess. So that's pretty nice. And I think he doesn't have any paid plans as well. It is totally based on funding, I guess. Yeah. Right, go to L2. Chess game. Yeah. Chess game in Python. I think a few weeks ago there was this guy on my stream. He made a chess game in Python. And he also created an AI version for it, which you can play with. It was not that much advanced, but it was pretty much good. So yeah, it is doable. Yeah. We can use Pygame module for the UI part. He had 2 versions of chess. One was the UI version, and another was the terminal version. So you can play the chess. Wait, was it chess or tic-tac-toe? No, I think it was tic-tac-toe, not chess. Yeah. Can you create a terminal based chess? Maybe you can create a terminal based chess. I don't know. You need to represent forward using some sort of. Still better than me. You mean in terms of coding? I don't know. was pretty much, was also a beginner, I think, and didn't write the algorithm for the AI. He borrowed it from someone else. Even I wrote a tic-tac-toe game when I was in first year of college. No, not first year, second year of college. It was made for Android. I wrote it in Java. It was pretty terrible. It was my first project, I think, a big project. Yeah. But I didn't get around finishing it. I implemented the basic stuff and I didn't work on it afterwards. That was the only project on that I worked on using Java language. After that, I think I didn't touch Java again. It's a pretty terrible language. Okay, now in this case, we don't need this part. We can use write if, not write if, write label, and we can pass L1 here. Nice. Okay, what do we need after that? The compile statement paths, and finally we need L2 label. So let's copy this, and should I write the L2 label? Yeah, probably label. We change this to L2, and this one L1. And here also I need to pass L. Okay. So that was easy. Alright, so now we need to take care of while statement. It will be almost similar, so let's copy the code from let's copy this thing. We'll have to get a label before we call compile expressions, so let's have it here. Right label, not L1, not L2, L1, and instead of if, it should be while, and oops, it should be while end, and this is while L1. while int. Instead of go to, I should call label. Awesome. Now we call compile expression, and after that, so let's copy the code from, where is it? Yeah, this one. After the expression part, we call write arithmetic not, and if go to L2, so this should be L2. Copy this. L2. Right. Wait, I need underscore here and here as well. This should be if. Okay. After that, the expressions, the compile expressions. Wait, did I mess up something here in the if part? Just the expressions, not expression, the statements. Right. I'll statements. So this compile statements would take care of multiple statements, right? So what happened with while then? Why didn't we write the same logic for while as well? Or did we? Oh, what the hell? We don't have the same logic for while. This is terrible. Why didn't we catch this bug earlier? We should have caught this earlier. And I need to check compile statements now. Compile statements. Holy we have multiple places we have placed this thing. What the hell? Because we are already taking care of multiple statements. Man, do we need to change it everywhere? This is if part, right? else. What about this one? Yeah, this is correct. Yeah, this is correct. Yeah, right. I got confused. It is correct. Everything is fine. You don't need to change anything. So then why don't we check for this here? If token not equal to this, because token can be this one, right? Oh, what the hell? I think this is incorrect. Token is equal to self token advance. Token is equal to this. Token can be this. It can be an empty. So need to need to remove this. Okay, now this is correct, because even though we don't need the while part, we still need the if part. We can have 0 statements inside if. Now this is correct. Yeah, so let's continue writing the VM code now. So where were we? The while. Is this if? Yeah, this is if. We need to check the while. Yeah, we need to copy. Let's see. We have written if go to L2. Then after that we compile the statements. We write go to lay L1. L1 and label L2. So let's copy it from here. Where do we have go to? Do we even have a go to? Yeah, have it. Go to after this. So the L1, and here as well it will be L1, and instead of if we'll have while. Here as well, same thing, while L1, and finally we have L2. We already have L2. Wait, we also already have L1. We don't need to get it again, so we got it here already, right? We need to get L1 again. Select this, and after this we have write label L2. We'll call self.pmw write label L2. So it seems we're taken care of both control flow. Hope we don't have any bug. But yeah, sure we'll have bugs. What's the next thing after and while? Handling objects and handling arrays. Wait. I will be back in a minute. Mm, okay, for this we do need to write the subroutine call code and return code as well as the main code. 1 2 matches. Awesome, man. So what's the score now? Is it 120 or sorry, 1000? Crying and playing dirty. Ah, playing on offensive mode. Is that it? you know, waiting at the wrong time. Yeah. When I try to play, I can't really play when, I'm under a time constraint. I can't really think. It paces me. My mind stops working when I have a, timer running, like 2 minutes timer, 4 steps. You wait in just 4 steps. Nice. Did you watch that series? This is called The Queen's Gambit. Steps. No all pieces. Tactics, folk, rules, and some solid opening. Now, in terms of opening, I know the basic concepts like what is it called? What is it called when you move all the pieces from the first row? Like I don't remember exactly the phrase. When you move your knight and bishop and everything into position. What is it? In the upper position. I don't remember exactly what it is for. And I know the rules like, chess piece values and so on. But after that, I don't know any tactics, any advanced tactics or any intermediate tactics as well. And games like King Queen. Yeah, I know how to play King Queen ending, but only that. Two rook ending. Learn trades and think 3-4 moves ahead. Yeah, I can't really think more than 2 steps ahead right now. I need to practice it more. Learn the trades. Yeah, so right now the only rule that I follow for trade is just the chess piece value, the basic rule. Other than that, I don't know, situational value. 1 step ahead only. I don't think so, do you? I mean, you have like a 1,000 score, you must be better. A compiler updates the subroutine symbol table. When do we update the symbol table for the class? So right now I think we are not updating symbol table, the class symbol table. Let me check the class symbol table class. Symbol table start subroutine. Are we even calling the start subroutine? Nope. Yeah, we already have this point. Yeah, we are doing this. We are creating this symbol table. Right. So let's get back to compile. This is really the code for the subroutine call when we have this kind of syntax. So let's go back to the grammar. Where does the subroutine call appear? It appears here, and where else? In the do statement. Yeah. In the expression, in the term, as well as in the do statement. Right. So we need to take care of the subroutine call in both of these places. So let's write the code for the do subroutine call first. I think it will be much more easier. Compile do okay. Call point dot new. Okay. Okay, we only have to push 4 lines of code. Right, so let's take care of it. From where does it start? Do subroutine call, subroutine name, class name, or the variable name. Right. Wait, this is just for the object construction, the constructor part, not the other subroutines, right? Compile, construction, manipulation, yeah. So we need to check other things. Let me check let statement. Expression. So yeah, it is part of the expression, subroutine call. And then the subroutine call is of this type. Well, what will be the form? Let me go in the let statement, compile that statement. What's the subroutine call part? Yeah, it's not a subroutine, it's an expression. So do statement, return statement, expression list, and expressions. Yeah, right. It's this case right here, and it is either a class or a subroutine. Wait a minute. Is this the only way we can create a new object? By getting the class and calling new? So point here is a class. Right? Yeah, right. What the? I need the class name as well as the arguments. And wait, these arguments can be variables as well, right? Can they be variables? Let me check the grammar. Subroutine call, yeah, it can be an expression list. So they can be variables, but it doesn't matter because it has been already taken care of. Right. Yeah, so the push part is already being taken care of. Am I right? So here we are calling, what is it? Compile expression list. Yeah, right. The token is dot subroutine name. All right. And wait, the expression list can be empty as well. Let me check compile expression list. Alright, so this is correct. So after we are done with this compile expressions, we should call point. Only in this case, else get, right? But wait a minute. It can also be, so let me check the grammar. The token is this or dot. What? Yeah, it can be expressionless directly or a dot. So what if it is a subroutine name? The process bit different. I need to check. Compiling what? Manipulation method codes. Okay, if this is the case, what the? Need to reload it. Compiling the methods. Yeah, right. Compiling the methods, compiling methods. Callers code. Push P1, push P2. Okay, this is nice. This is nice. Okay, code will be similar, right? So we can directly do what? So after this file expression, we can write VM code for call what will be the form? Sub subroutine. It can be either a subroutine or a class name or a variable name dot the method, not the method, the subroutine. Wait, it can't be a subroutine. Variable name subroutine, class name dot subroutine. This is probably correct. So now we need to call self.vmw dot write call. What's the method name again? Write call, yeah. Write call, and we need to pass the name of the method and the number of arguments. Okay, so this is a bit tricky. What will be the name of that? So in this case it is point.distance. Well, we need to know the type. Oh yeah, I think we can use the symbol table for this thing. And I think I'm gonna keep this for tomorrow because it involves a lot of things and it's almost time to wrap up this project today. So we'll continue from this point onwards from tomorrow. So do write the code for calling subroutine. Let me comment. Let's just keep it. Okay, so we'll wrap up. This is it for today. What did we do today? We wrote code for the expressions, right? This code. Yeah, so let me close all of it. Oops. Compilation engine. What should be the commit message for today? Wrote VM code calls for expressions partial. This is an apt message, so hey DataDev, are you still here? Are you still online? Alright, then I'm going to end this stream here, and I will see you guys tomorrow. Goodbye.